Okay, so there's different judgment calls of what we can do next. There's some stuff that's not working yet, right? Like for instance, I could type in here an invalid move. There's no checking, right? If I said row -2, column 6, right? We're lucky that didn't cause the program to crash. It just didn't display anything. Okay. So one thing we could do is check that the move is valid and let the user know, right? I'm actually going to come back to that, okay? And instead, let's make this in a loop where we can, because right now we're having one move, right? Let's make it so there's multiple moves, okay? That there's multiple moves. So that, again, you can make a judgment call on what would be appropriate next step. But I'm going to choose that the next step is multiple moves. Okay. And even this step, we're going to break out into multiple pieces. Now, for multiple moves, what we don't want to do is make this big, long, massive program where we're copying, pasting things over and over and over and over again and make this program massive. It's much better to have a loop, okay? And I'm going to do something where we're going to continue to... I'm effectively going to make what's called an infinite loop, okay, where this game is going to go forever. Okay, typically you want to avoid doing that. And I'm going to add the standard Boolean library so that we have true, right, so we can use true. Now, this is a caveat, right? Well, what this will do is it's going to continue to ask the user. Actually, let me run it and show you. But it's going to continue to ask the user over and over and over again to the end of time if the to enter a row and a column, right? And continuing to make that move, right? Now, all the moves right now are X, right? So if I said row 1, column 2, right? If I said row 2, column 2, right? It's just going to keep going, right? 3, 3, whatever we did. Okay, it's just going to keep going until I terminate the program. Like I force terminate. I could either hit the stop or hit Control C to force it to quit. Now, obviously, that's not really the ideal scenario. There's different ways that we could build this to quit, but for now, I'm going to leave it that way. Okay, that the game just continues to run forever, right? There's not often times that you want to do that, although you do see certain types of programming where that comes up. But typically, you avoid these kind of infinite loops. Now, in the best way for this game to end is for it to detect when the game is over, that either player has won or the game is permanently tied. But we'll come back to that. Okay. So now notice this isn't really a real game yet. Right now it's all X's, right? So maybe a next step here is to allow multiple players. Maybe we want to allow multiple players. Okay. So we could do that. Right? And a good way of doing that is to keep track of whose turn it is. Okay. So I'm going to keep track. I'm going to declare a variable. I'm going to call it turn. And the goal of the turn variable is to keep track of whose turn it is. Okay, whose turn is it? So we're going to say the turn, we're going to have X start. Okay. And after, let's have this line up correctly. See proper indentation. After the player plays their move, okay, we're going to change it and we're going to go to the next turn, right? So if turn is X, we're going to set turn to O. Okay, else turn equals X, right? So basically, if it's X's turn, it's O's turn next. And if it's O's turn, It's X's turn next. We're going to swap. Okay, and we need to be careful that we change this here too, because when we actually write the data to the two-dimensional array, we want to make sure that we're writing whose turn it is. Otherwise, it will still always write X, okay, each time. Now, this moves us in the right direction, right? And again, I want to compile and test often. This moves us in the right direction here because we can go and say, okay, I can actually play a decent game now where we could say X goes here, right? And now notice it's not actually displaying whose turn it is. So we probably want to do that too to have it say it's O's turn. But it is now. It's O's turn. So if like O went up in the corner, okay, now it's X's turn again. Maybe X wants to go in the other, down the lower left corner, for instance, okay? And we can continue, we can play a game that way, right? Now, there's a weird thing that can happen here though, right? There's a couple things. One, we're not displaying whose turn it is, so that would be a reasonable next thing to do. The other thing is we're not checking for valid moves because there's nothing that prevents, like notice, look at the board right here. There's nothing to prevent O from going like this. Say, hey, I want that center spot. So I'm going to go ahead and just say row 2, column 2 and take it. Okay, and that's obviously not a valid way to play the game, but there's nothing right now in the programming logic that's preventing us from doing that. Okay, so that's another thing that we want to tackle. So I would say there's probably two things we want to do here. We want to display the player, okay, so we know whose turn it is, okay, and then we're gonna look at checking for valid moves. Checking for valid moves. So let's display the player first because that's an easier thing to implement. So we'll just do that up here, right at the, we'll say turn is, and then it's a character. We're just going to display whose turn it is. Okay. And, you know, what might even be helpful to be able to see it is every time we go to a new turn, maybe we'll have a little bit of a divider too, just to kind of see that it's now the next turn. It's a design choice, right? So we did that. Okay, let me make sure that that is supposed to have a P there. Okay. The next thing that we would want to do, right, it says let's check for valid moves. Okay, let's check for valid moves. So we can say if for row to be a valid move, right, it should be greater than or equal to 1, right, and row should be less than or equal to 3. Okay, that would be a valid move. Let's actually do it the opposite though. Let's say if, for anything that's invalid, right? So if row is less than 1, it's an invalid move, right? Or if row is greater than 3, it's invalid. Or it's the same thing with column, right? If any one of these is true, right? If any one of those is true, the move is invalid. Okay. Now, one way we might even want to do this, we could break it up into multiple spots. We could check after each thing. We could check right after they enter the row. Okay, I'm going to do it all at once. It might not be the ideal, but it makes things a little easier. Okay. The other thing, right, if it's invalid or, right, if the board well, let me test this first. Let me show you this first. What we'll do is if they enter a wrong location, let's actually print something. Invalid move. Okay, we're just going to say that. Okay. And then we'll look at how to improve this later on. Oh, and we have a wrong number of arguments. Oh, you might have noticed there's a compile error here. Let's go ahead and let's fix that. Okay, it was right in front of me, didn't even see it. Let's compile again. Okay, so now what it should do, if I type in something invalid, right, it should say that it's an invalid move. I forgot the new line character here, so that'll fix that formatting. Okay. So there's a couple things that are wrong though, right? Notice it was X's turn. The X made an invalid move, and then it went to O's turn. Well, that doesn't really make sense, right? Like, so if X does something invalid, right, they're losing their turn right now. So we should fix that, okay? The other thing that's going on, right? Let me right, make a move. So it's now, the other thing that's going on is it's still allowing X to take a location from O, right? So if X wanted, or either way, it could take a spot that's already free, or it's already used by something else. So if X wanted to take the center, right, it's still allowing that. Okay, so we've got a couple of those issues to address. All right, so if we come back to what we're trying to do next, right, for checking for valid moves, there's a couple pieces to this. There's a range checking piece, right? And that's effectively making sure that the row and columns is between 1 and 3, okay? The other thing is we want to make sure, right, for checking for a valid move, that the space is available. We'll say space is free. Right. Well, how do we know if the space is free? Right. That's, we kind of go back to how we initialize the board here. Right. If it's a blank space, it's free. Okay. So we want to check that too to determine if it's a valid move. Let's do that first here. Okay. So here we're saying if it's an invalid move. So we'll say or board row -1, column -1 if it's not equal to a space. Okay, let me make sure you can see this whole statement here. Okay, remember we're using ors for all of these. If any one of these is true, it's an invalid move, right? If you entered a row that's too small or too big, a column that's too small or too big, or if you are trying to go into a board space, right, that's not blank, any of those is going to result in an invalid move. Okay. Any of those is going to result in an invalid move, right? And it's going to display that, right? However, now all it's doing right now is it's displaying it, but it's not doing anything, right? It just tells the user that the move is invalid, okay? And we could see that, right? If I run it and test it again, we're gonna be able to observe that here. Let's see. I must have one typo. Oh. Okay, I had an extra square bracket there. All right, if you were able to see that. Let's run that again. Let's see. Expected. Oh, square bracket was supposed to be right there. Okay, now, right, it's your error messages are your friends. Right, I got an error message here. And taking a look at this error, let me make it a little smaller so that we can see it on the screen here. Notice this, some error messages are better than others, right? But this one was really good, right? It's saying subscripted value is neither array nor pointer nor vector, right? Well, that might be very cryptic to you, but effectively notice that it's telling you which line and even where in the line there's a problem. It's exactly where the problem was. Okay? All right, so sometimes they're more helpful than others, right? But that told you that in this case it told you right where the problem was. So that we can, fairly easily fix it. All right. Now, once again, this solves some problems, right? Like if I go in the middle, now if O tries to go in the middle spot, right, it tells them that it's invalid. However, it's still allowed O to take the spot, right? So let's fix that next. And I'm going to use something that the easiest way to do this is I'm going to use a term called continue. Okay. Notice that when I type it, it becomes blue. That indicating it's a reserved word, something built into the language. And well, what is that going to do, right? Is if we hit this line, what that does is it skips everything else in the loop, in the code block that we're currently in, right? We're in this loop here, right? We're in that loop, this while loop, this infinite while loop. Soon as that hits, it goes to the end of that loop, right? And then it continues on running the next iteration, okay? If I did something called break here, it would quit and leave the loop entirely, immediately, and in this case, end the program, okay? So you want to be careful with when you use these. You want to have a very good reason for using it. In this case, that's exactly the functionality we want. If it's an invalid move, we want to not make the move, right? We don't want to display, right? We just want to come back around and allow the person to redo their turn, okay? So that makes an awful lot of sense to use it in this case, right? Now, let me comment here as well, just to keep the code organized. Range check to detect invalid moves, okay? Okay. All right, now we'll see that with continue, right? It'll hit that line and immediately stop this iteration of the loop, come back around and run through the loop again. Okay, so if I run this, we're going to now see that the game is pretty good. It's pretty good, right? And say maybe I take the middle, right? Now it's O's turn. If O tries to do something like take the middle as well, right? It says it's invalid, and notice, crucially, notice that it's still O's turn, right? O made an invalid move because X was already there, told him it was invalid, and then let that user redo the move. Okay, if O does another invalid move, right, it's gonna continue to ask them forever, right, until O has a valid move, and now the turn changes to X's. Okay, and we can continue playing the game.